And we are live. What is up, everyone? Welcome back to the HackSmarter Twitch channel, or if you are watching this after the fact, welcome to my YouTube channel. My name is Tyler Ramsbey, and we get to hang out this evening and do some hacking stuff together. Want to say a special hello to HunterBot and Bottleneck, and it looks like a few other people live. Just talking in the chat about the stream last night. Yo, that was crazy. So those who weren't aware, who weren't part of it, when I started streaming last night, I hadn't been on very long, and I got raided on Twitch, which I've been raided a few times, but usually when I'm raided, it's like, 20 to 50 people will come and join the channel. Like nearly 600 people joined the channel all at once last night, and I don't usually get like stage fright. I'm pretty comfortable speaking in front of people, but that was too much. The chat blew up and it was overwhelming. So I'm hoping I don't have 600 people on. I'm not yet ready for that level of people watching, but it was still fun. It was a cool experience. But we are going to dive back into things. I know I said at the end of my stream last night and at the end of my video, if you're watching this on YouTube, I said like I'm burnt out on this AWS path and I'm done. I'm going to do something else. And then I slept. I went to bed, which is always a good idea, and reconsidered. And we are going to dive back into the AWS path because I'm so close to being done. And my goal in the beginning was to stream the entire pathway as long as it's not too buggy. I did have a lot of bugs with it yesterday before going on stream and didn't think I was going to be able to do it, but I got it working. And then today I had to reset the environment twice again, but I think everything seems to be working. So I think we're good to go. We are going to attempt the pathway again, but tonight, we're going to begin with the challenge room, so more of a CTF, more hands-on, and we will see how we do. As usual, I have not prepped this ahead of time, have not gone through it, so we are going to go through it live. Let me go ahead and share my screen. And actually, before we dive into this, let me just show you guys kind of where we are at. If we go back to our pathway here, here's where I don't want to be done yet. I want to see if we can finish this. I finished all of that, right? I finished all of that. I'm in the attacking and defending core services. We're going to be at this one right here. And then Cali Max, I believe, recorded both of these, and he recorded maybe two of these. I don't think all three. So I don't even have to stream all of this. What I'm doing with Cali Max is the parts that he streamed, he sent me the recordings. So I'm just going to use those to continue the series. So between me and Cali Max, we are just about done, and we'll have this entire pathway live on YouTube for anyone to watch without being behind a paywall, and then people can learn AWS pen testing and get a feel for what the attacking and defending AWS pathway through TryHackMe is like without having to have a business account and then paying on top of that. So let's dive into AWS VPC data exfiltration. Yesterday or last night, we covered attack and defense. And like I said before, it's a challenge room, but it's kind of a guided challenge room, which is good because I would be lost without that. I'm still like so confused by AWS. I'm starting to understand some of the basics, but I've done like so many cloud goat scenarios. I've done almost this full pathway, and I still feel lost so often with AWS. I feel like it's needlessly confusing on the AWS side of things. And in the intro room, it kind of explained some of the reason for that, or for the weird naming conventions. And so I think I'll probably just always be confused a little bit, but I learn a little bit more each time I work through each one of these rooms. So hopefully I'm a little less confused by the end. But let's go ahead and dive in. It says, congratulations. You've just found AWS creds for a network engineer at your target. Your mission, if you choose to accept it, is to reconfigure their secure network so you can exfiltrate the secret plans for the next generation of space weapons. Oh man, we're like on Donald Trump's, what's that organization he called? Like the Space Army or the Space Warriors, the Space Force. That's what I'm looking for, the Space Force. So we apparently have hacked the Space Force. The plans are all in the EC2 instance named Engineering Wiki. And because they think their wiki is secure inside their network, it's available on port 80. So here's our goal. Reconfigure the route tables, security groups, and maybe NACLs so you can curl that EC2 instance from our attack box, which is why I have the attack box going, because I'm guessing we'll need a public IP again, and enter the name of the secret weapon. For this room, your access has been demoted to that of a network engineer. You can modify resources, but your ability to see things in the management console is limited. You can still use Cloud Shell if that is your preference. So here is our management console. If we click like VPC, let's just see what we can see. Okay, so I'm pretty sure this is on purpose. You can see what we can see is quite limited. Can I see subnets? I can see subnets, but you can see I cannot describe the availability zone, so I probably can't see. Oh no, I can see the availability zone, I think. But it's limited, so I'm guessing we're going to be doing most of this through the CLI, which I enjoy learning about the CLI. So let's get started. Accessing the environment, this is the stuff I already did. Just for those who might be following along on your own, for this one right here, you do have to regenerate the cloud environment. So the cloud environment for the attacking and defending VPC, you have to reset or regenerate because you need different roles for this scenario, but I already did that before jumping on stream. Okay, task 3, or really step 1, assign a public IP address on the target instance. The target EC2 instance doesn't have a public IP address. So if we're going to target it from our attack box, we'll need to assign one. We first need to allocate a new public IP address to the EC2 instance in this account. Okay, let's back up because I understand maybe for the CTF, it's saying, hey, there's only one EC2, but in the real world, there might be more than one EC2. So we have to see like what EC2s are in the account. So just for our own memory, let's see if we can remember how to do that. I think it's AWS EC2 describe instances, I think. Hey, okay, I was right. I'm glad I actually remembered a command. So if we look at our instances here, we have this instance ID, we have the AMI, and we have the availability zone, US East 1A. We have a private IP address. We don't have a public DNS name. And yeah, I'm guessing we must not have a public IP either. We have that hard-coded DHCP assignment. Here's our engineering wiki security group. So that's what we are going to be reconfiguring from what I can see. We have a private DNS name, private IP address. Okay. And so it does seem to be only, if I'm understanding this correctly, there's only, I'm going to turn off my desktop audio so you guys don't hear that silly clicking from the attack box. I think this is the only instance, right? So if you look at instances, I don't think I saw instance anywhere else. This is all just describing this one instance, right? I think. Yep. I have to reset my terminal because for some reason the AWS CLI breaks the attack box's terminal, and it also broke my parrot's terminal, but it does work in Kali, so I don't know the differences in why that works. So first we need to allocate a new public IP address. So let's go ahead and do that. AWS EC2 allocate address, and I'm guessing if there was more than one instance, we'd have to define like the instance here, but because there's only one EC2, this might be the only command we need to do. Okay, beautiful. And then it says, remember this public IP address, you need it in a later task. So let's go ahead and just copy this command, and we'll open Sublime Text, and we will just drop it in there so that we have it. We'll use this kind of as our running notes as we work our way through this scenario. Lightspeed said, what distro are you using? So this is actually the attack box through TryHackMe, which, you know, oddly enough, we're doing AWS. This is actually an EC2 hosted in the cloud, but it's a customized Ubuntu VM. Now we need to find the ENI, or the network interface for the target machine. Not every AWS CLI command requires elegant use of query and filter, so we can use the grep command in this case to get our result. So we were actually working a little bit ahead when we were looking at the full describe instances. So let's go ahead and follow along. It's AWS EC2 describe instances, and then we're saving the output to instances.json. And if we cat that, we can see everything is there, and then it doesn't break our terminal, so that's good. So what we want to do is if we grep, we're looking for the ENI, so yeah, we'll grep the ENI and the instances.json, and there we go. We have this information here, so let's go, oops, I don't mean to scroll up. Let's go ahead and grab this and add, jeez, stop doing that. We'll grab that and add that to our notes as well. There we go. Now we attach the public IP to the ENI of the target machine by associating the allocation ID with the network interface ID. Okay, I think I understand that. Although we could copy it, I want to type it out just to build that muscle memory. So we're doing AWS EC2 associate address, which makes sense, network interface, if I could type interface ID, and then we want to pass it that network interface ID that we just grabbed. So let's open up our notes. The network interface ID is right here. So we will copy that, paste that in, and then allocation ID, and that's from the previous one. So we'll go back to subl. And here's the allocation ID right there. And that's for that public IP that we assigned. Okay, so far so good. There is our association ID, and that's different than that number, right? So I'm actually going to copy that as well. I don't know if it's going to come up later, but I'd rather have it and not have to redo our commands later on. Whoops. There we go. All right. Note, the network interface ID and allocation ID will be different for every user. Use the values you discovered in the commands above, which we did. Open another window on your attack box and start a ping against the above IP. This will help you know whether you've succeeded in exposing the private wiki interface. So that's a good idea. So we'll just open a new tab, and we'll just run a continual ping. And I suppose once we make the network no longer secure, unsecure, insecure, weak, our ping will respond to us. Right now it's not going to respond because we need to hack the VPC and make it insecure. So we'll just let that ping run in the background. What is the value of the public IPv4 pool in the AWS EC2 allocate address response? I don't know, but we should have it in our notes. Just Amazon. Boom. All right, let's keep going. Change route table allowing a private subnet direct internet access. Just because your target instance has a public IP address doesn't mean it can be reached from the internet. And we can see that our ping command is not going through. You also have to ensure there's a route from the internet to the target. And this task will establish a route from the internet, represented by the Internet Gateway or IGW, to the subnet the target resides in. So first, get the IGW ID. You will probably have two in your account. One is for the default VPC and won't have any tags. The other will have tags. Okay. So what I'm going to do is if we do AWS EC2 describe internet gateways, and I'm going to save that as igws.json, because then it doesn't kill our terminal. And then we are looking for the IGW ID. Can I just grab ID on that? Are those the two IDs? I might have to actually look at the output to see, you know, what has tags. Those in a small output. So it said one of them, you'll have two in your account. One is for the default VPC and won't have any tags. The other one will have tags. By tags, do they mean value? We have the VPC capstone IGW. We have, this is the full value for the stack ID. I only see one internet ID. And I think, and these are the tags. Okay, no, I'm just not reading the JSON properly. These are all the tags for it. So this would be the Internet Gateway ID that we are looking for. And so I'm going to go ahead and just copy, we'll copy just this information right here. We'll go copy and we'll go over to subl. Oh, come on, subl. Looking over at the chat, Skinny Slim Thick said, first, did you get MVP for the name? And guys, what I want to do is get the Twitch overlay on my screen. So those of you on YouTube can see the chat as we're going, so you don't feel so left out from the Twitch stream. I'll work on that. Me and Protag. Where we left off after OBS crashed on me during that raid. First, if anyone hung around after the raid and after OBS crashed, appreciate you being here. We are working through the Attacking and Defending AWS Pathway by TryHackMe. It's a business exclusive, but I've received permission to stream it. And we are doing one of the challenge rooms, which is data exfiltration through AWS VPC. So we are going to just pick up where we left off. And like I said before, I'll redo the first part of the video offline and we'll splice it all together with some editing magic. But here we go. Where were we at when everything broke? We needed to get the IGW ID. Okay, that's where we're at. We probably have 2 in our account. One is for the default VPC and won't have any tags. The others will have tags. Okay, so we have that. Now get the route table ID. You want the one with the tag name VPC capstone private route table. So let's go ahead and do that. EC2 describe route tables, and we'll save it to route tables.json. And if we do grep, oh, but we need the full ID, so I guess I'll cat that. I don't know what it looks like. A2N mod said, did you guys hear about Kevin McNick? Yeah, dude, I just read about that a little bit before going on stream. For those who aren't aware, Kevin McNick passed away from cancer, man. Cancer freaking sucks. He had I think his first kid on the way, if I understood the obituary correctly, but really sad news. What am I looking at? If you guys haven't read his books, would recommend reading them. I've read Ghosts in the Wires. I remember reading that one. Gosh, there's a book on social engineering that he wrote that I read, and there's a third book. I'm blanking on that name as well. I love reading, guys, so I'm always reading different books, both fiction and nonfiction, so I get them all kind of mixed up in my head. But incredible leader, incredible teacher, incredible author in just so many ways. All right, get the route table ID. We want the one with the tag name VPC capstone ID. So here's our VPC capstone public route table, and we want to get the route table ID, which I think is going to be that right there. So we'll go ahead and copy that and drop it into our notes. There we go. Okay, now you're ready to add the route to the route table like so. Note the RTB and IGW identifiers will be different for each user. Okay, so let's give this a shot. AWS EC2 create route, and then we want to pass it the route table ID. So let's go ahead and grab that route table ID. We'll go from subline text. Here's our route table ID right there. Route table ID, and then destination CIDR block, and then we want to be open to everything so that it can reach out to the internet with no issues. Gateway ID, and then we're going to pass it that gateway ID we got. Okay. So by specifying that CIDR block, you're telling the route table to send all traffic, and that's kind of what I figured. Hit enter. Let's see if I had any typos. Okay, cool. No typos. If you rerun the AWS EC2 describe route tables, you should now see this as one of the routes on the private subnet route table. And I'm just going, well, I guess we can run that. So if we do AWS EC2 describe route tables, and we'll save that to route tables2.json. And if we grep for, I think it would be this gateway ID right here. Gateway ID is in there. And I guess we could also grep for the destination block, because that will show us, you know, whether or not it added properly. Whoops, 0.0.0. Let's see if that, oh, I can't freaking type. There it is. So I'm assuming it's there. Everything seems to be working well. And what is the name of the IGW? Did I save that information to Subble? No, I didn't, but it should be. I think it would be here. We have. Am I blind? Am I looking at the wrong thing? Here's the one that we added. Our route table ID, but what is the name of the IGW? How did we get the IGW information before? Was it, oh, describe internet gateways. And I think I saved that if I cat igws.json. Is it this? Hey, beautiful. Okay. Modify the security group to allow access to the world, which means I think technically you guys would be able to access it on Twitch. I don't know if you trying it breaks TryHackMe stuff, but technically if I'm opening this to the world, and this is actually hosted in Amazon, you guys might be able to access it. Right now our ping should still be failing. Yep. You've now established a route to the target instance's subnet, but your traffic is still blocked by a security group. In this task, you'll use the compromised network creds to cut a hole in their firewall to access the target instance. First, you will need to find the group ID of the engineering wiki security group to ensure it is open to allow you access. All right, let's go ahead and do that. So AWS EC2, describe security groups, and we'll save that to security groups.json. And we're looking for the engineering wiki security group. So if we cat that, how big is that? Okay, not bad. So the group ID of the engineering wiki security group, we can see the group name there. I'm guessing, is it this group ID? No, that's the, okay, hold up. I need to scroll up, I think. So here is a tag, which is the engineering wiki security group. Stop scrolling, stop. I wasn't doing that. Oh man, it scrolled way up. Stop it. It's lagging out on me. Hopefully OBS doesn't crash again as well. Oh, it scrolled way too up. Okay, super secure security group, engineering wiki security group. And here is what I think would be the group ID. Open up security groups JSON and look for the group ID of the security group called engineering wiki security group. Next, create a security group to allow all traffic from anywhere. And I think once we do this, that ping will start going through. We'll start to see responses from this ping. And technically, those of you on stream would be able to ping it yourselves. Okay, so AWS, EC2, authorized security group, ingress, protocol, all, port. And then we'll grab that group ID. Wow. I think it might be my computer, but attack box has gotten really laggy on me. But I think that issue's on my end, not TryHackMe's end. Okay, cool. Does our ping start working now? Unless I did to the wrong group. Because security groups are stateful, you use the command authorize security group ingress to create a rule allowing all ports from any IP address for all TCP, UDP, and ICMP, which is the protocol all. What is the description security group you just compromised? Well, I'm not sure if I actually compromised it properly. It's not wanting to scroll very well for me, but here we go. So the description, I think, is the super secure security group, right? Let's go ahead and copy that. Okay. Make sure I grab the right one. So this is the security group. CIDR IP allow all from 10.8, which is IP permissions for that. But I think this is the group ID, right, for that, correct? Maybe not. Oh, no, yeah, that would go together. That would be the correct security group. That's the one I put in there, right? Yeah. Oh, we need to fix the NACLs to allow access. Okay, got it. Boy, this engineering wiki has a lot of defenses. You know, just being in AWS alone has defenses, because if it was just me, I wouldn't be able to compromise it. Security through obscurity. Luckily, we have the hot knife of compromised creds to cut through them. Our next layer of defense to cut through is the network access control list. Let's go get the information we need about them. So AWS EC2, describe network ACLs. There we go. Look through that file for the NACL called VPN capstone private subnet NACL. You need to find the NACL, which begins with ACL of the one you want to edit. The ACL entries for your target NACL should look like this. Okay, so we need to find the one with the VPC capstone private subnet ACL. Gosh, it's not wanting to scroll well for me. Oh, stop scrolling, stop scrolling, stop scrolling, stop scrolling. Stop it, attack box. Okay, I think I saw it down here. So we want to edit the one with the VPC capstone private subnet ACL, which is right there. And that it would be the tags for this network ACL, right? The ACLs for your target NACL should look like this. Yeah, I think this would be the network ACL we're looking for. I have a second monitor over there, so it sometimes doesn't pick it up the best. As you can see from the above, do I need to do a command yet? Oh, we need the ACL. Oh, we got that. Okay, perfect. As you can see from the above, only the VPC CIDR range is allowed to talk to this private subnet, which will not work for our evil purposes. There are 2 rules defining the egress or outbound traffic and 3 rules for the inbound or ingress traffic. The last rule for both ingress and egress, rule number 32767, is always a deny. We learned about that in the previous stream. The following command will create a new rule at the top of the evaluation list. So we're saying a rule number 1, so it evaluates it first to allow all traffic from anywhere to the subnet. All right, I think I'm tracking. Protocol 1. So that's the rule, or no, protocol. First, if I could spell protocol. Rule, action, allow. And here's where we're setting the priority. So we want it to be rule number 1. And then we're saying, hey, do this on this network ACL ID. So let's grab that. It says, note the command will not return any output. But wait, there's more. It's important to remember that NACLs are stateless. Just because you're allowing your traffic in doesn't mean the return packets are allowed back out. So we have to create an egress rule as well. Okay, AWS EC2, create network ACL entry CIDR. Protocol action allow. I know I could copy and paste this, but once again, I think it's important with these long AWS commands to type them out just so you begin to build some of that muscle memory, because I've been typing these all the time and I still don't have that muscle memory. Bingo, our ping window should now show we can hit the public IP we assigned to the engineering wiki. I'm sure I did something wrong. Well, shoot. Where did I go wrong? So close to being done, but now I have to like retrace my steps. Shoot, I could just redo the entire thing since OBS crashed in the beginning anyways. Because I'll have to go back and re-record the beginning portion of this for YouTube. But I'm just not quite sure what I missed. Clearly I missed something though. So we have network ACLs here. We have ACL ID 08. These are the same. And we have our entries here. So we have this CIDR block from here, true, allow, true, deny, false, allow. I feel like it didn't. This is all just the same ACL ID. Right, so this matches the other one, so I didn't like do the wrong one. I am kind of stumped. I have no idea what I'm missing. Oh, hold up. This is what I added to. Did I edit the wrong one? No, I don't think so. It would be this ACL, right? Well, why is it applying it? Meebman said you could always limit it to only your IP. Yeah, I suppose I could do that as well. I mean, it obviously doesn't matter because I can't figure out how to get it to work either way. I have no idea what I missed. And this, guys, is why I am not a fan of AWS. I'm always confused. It feels like when I first started learning Active Directory pen testing, except for now I kind of understand Active Directory pen testing. I still don't understand AWS. It's so overly complex for seemingly no reason. So if we back up, where would I have missed it? Do I need to open a security group and look for the group ID of that? Did I somehow grab the wrong security group? I don't think so. Quite certain I grabbed the right security group. Maybe I will be done streaming the attacking and defending pathway. I don't think this is the pathway's fault right here. I think I missed something. I just don't feel like redoing every single step to figure out what I missed. Like I need to figure out a way to like verify steps as we go, but y'all saw me do it. I don't think I missed anything. We assigned the public IP address. We couldn't really mess that up, right? We would follow along with our steps. So we assigned the public IP address. You couldn't screw that up. We remembered it. We need to find the ENI for the target machine. not every command, blah, blah. I don't think we screwed up the ENI either. That was also pretty straightforward. And now we attach the public IP to the ENI of the target machine by associating that. All right. I think we did that. We ran the command once again. I don't think I could have screwed that up. Change the route table, allowing a private subnet direct internet access. We got the IGW ID. It says we'll probably have 2 in our account. We only had 1 in our account, so maybe that's where I broke it. So, internet gateways, I only see 1 IGW in my account, and it says you'll want the one with tags or whatever. So that's this one, and we have 3 tags. VPC capstone IGW, so this has to be the right IGW. It ends in 9F, and ours ends in 9F, so I did that right. It says now get the route table ID. You want the one with the tag name VPC capstone private route table. I believe I did that right as well. Just retrace our steps. A VPC capstone private route table, the one with that tag name. So here's the VPC capstone private route table. Those are our tags. And we want the route table ID, which looks like that. It starts with RTB. And so here's our route table IT, ends in C19. Route table IT. Oh, I think I figured out where I went wrong. If I'm looking at the right thing, where did I get that route table ID at? How did I do that wrong? Did I grab that one instead? Oh, I think I figured out my mistake. Like I said, not TryHackMe's fault. My fault / I'm just going to blame AWS. Okay, so now I'm going to copy and paste just so I can figure out like what I'm doing wrong. So if I replace the route table ID there, and then I need to grab the IGW from right there. That's what I was doing wrong. Look at that. Pay attention to the details, and to troubleshoot, just rework your steps. And honestly, I guess for those of you watching on YouTube, I talked about redoing those first couple of steps. I basically just did it now, so I'm not actually going to record this again because the only steps we missed before OBS crashed were these very basic steps in the beginning, and I literally just redid them myself anyways. So you shouldn't feel lost. And now the question is, how many subnets are associated with the VPC capstone private subnet? I don't know, 1. How many subnets? I think I actually saw this on here. 1, 2, 3, 4. Saw that in the console. Oh, never mind. How many? With the private subnet. How many subnets are associated with the private subnet? Would that just be 2? There we go. Mission success. You've succeeded in exposing the previously secure engineering wiki. Open the public IP address you allocated to download secret plans and answer the question below. You can use curl or a web browser. All right. Real hackers use curl. What is the name of the secret space weapon? The answer to the question is this. Boom. Got stuck a little bit there. OBS crashed in the process, but we still accomplished the challenge. And let's remember what we did on this challenge. If we go to the mission brief, we reconfigured the route tables, we reconfigured the security groups, and we reconfigured the NACLs so that we could curl to the EC2 instance after we gave it a public IP even from the attack box, and we got the name of the secret weapon. So that is the AWS VPC data exfiltration module on the Attacking and Defending AWS pathway by TryHackMe. I am, let's see, so I think this guy is the creator of it. So we have 1, 2, the great Cali Max, 3, and then 4. He's staff, so he doesn't count. So I'm the 4th person in all of TryHackMe history to finish this module. So that's exciting. What we are going to do now is I'm going to tear down this cloud environment, and we have to start a new cloud environment. But that can take, upwards of 5 minutes, sometimes even 10 minutes. I'm hoping it will be done in 5 minutes. So for those of you on YouTube, thank you for watching. After this video, just jump to the next one and you can continue learning AWS with me. So for those of you on YouTube, peace out.